Good morning, students. So in the last class, we are explaining about the P block elements, and we have seen how many different blocks are present in P block elements. So, and for your syllabus, as I said, it is from group 15 to group 18 for the second PU syllabus. And further, we have also seen in case of group 15, the different elements which are present in group 15, and we have seen the general electronic configuration, that is general features, and overall general informations like physical properties also we have seen. Along with that, the chemical properties like reactivity with a different substance, like reactivity with hydrogen, and what will be the reaction or what will be the product formed when it reacts with oxygen, like it will convert into the oxide form of E2O3 or E2O5, that is trioxide and pentaoxide, that also we have explained. Similarly, when it reacts with halogen, it will convert into halides of two forms, that is trihalides, which means reacts with the three halogen atoms. And if it converts into pentahalide, which means it will react with 5 halogen. Based on the oxidation states of the elements in case of group 15, they have ability to form various compounds with the help of different reactions that we have seen. Similarly, reaction with metals, it will convert into binary, right? So binary compounds, that also we have seen, and we have given more examples even on the cases of reactivity towards metals also. So the next important part in this reactivity, after the reactivity or the chemical properties of 15 group element, is there are some examples like preparations, right? So there are some preparation for your syllabus. So in that, one important one is preparation of dinitrogen, right? So generally for your syllabus, they have given the laboratory measurement, laboratory preparation. So which means at small scale, at very less value, or at very less concentration, how we can prepare the dinitrogen, right? So dinitrogen is nothing but N2. The molecular formula of dinitrogen is N2, right? So this N2 can be prepared in a laboratory. So by treating aqueous solution, which means which is in the form of water molecule, that is aqueous. Aqua means water. So the aqueous solution of ammonium chloride, here if you observe ammonium chloride, right? So that is NH4Cl. When it reacts with sodium nitrate, that is NaNO2, right? So whenever the ammonium chloride reacts with NaNO2, so due to the reaction, there will be a liberation of nitrogen, that is generally called as N2. N2 means dinitrogen, right? So along with as a side product, we are getting water molecule as well as salts also prepared, that is NaCl, right? So NaCl is a salt, that is sodium chloride. It's a very simple reaction. They may ask for 1 mark, right? So write the preparation of dinitrogen in laboratory. Laboratory means at very small scale, right? So, and the second type of preparation will be industrial scale. Industrial scale means for a large scale, right? For large scale, whenever we produce, we will call it as industrial scale. And in case of laboratory scale means it is just like a testing. And whenever you need for the very less concentration, then we'll go for the laboratory scale. And therefore, in the preparation, during the preparation of dinitrogen, in case of laboratory, so by treating ammonium chloride, the NH4Cl is ammonium chloride, when it reacts with sodium nitrate, right? So after the reaction, what happens? There will be a formation of dinitrogen, right? So our aim is to form the dinitrogen, that is a main product. Along with that, there will be a side product. There is a formation of a side product like water molecules are liberated. Similarly, sodium chloride along with that salt is also prepared in presence of dinitrogen, right? So this is one of the important reactions for the preparation of dinitrogen, which can be asked for 1 mark. And if you see, there are various properties. After the preparation, we'll see some properties. What are the important properties of dinitrogen, right? So dinitrogen is colorless, odorless, and tasteless, and a non-toxic gas, right? So dinitrogen is generally in the gaseous form, right? And that is N bonded with N, single bonded, double bonded, triple, like this, right? So the properties of the first important property of dinitrogen is colorless, odorless, and it is tasteless, and it is a non-toxic gas, right? So it is harmless even if in case of atmosphere. So it is harmless. We'll call it as non-toxic gas, right? And nitrogen has 2 isotopes, right? So this substance or the elements having a same atomic number but different mass number, generally we know that those are generally called as isotopes, right? So the elements having same atomic number but then mass number is different, which means the element can present in more than one form, generally we'll call it as isotopes, right? So nitrogen has 2 isotopes. One is N14, nitrogen 14, another one is nitrogen 15. And third important property is it has very low solubility and low freezing and boiling point, right? So solubility means when you dissolve in water, right? So its solubility is very less, and similarly low freezing and low boiling point. It can easily boil at a very low temperature, and it can freeze at very low temperature. Since it is a gas, so it can be freezed or it can be boiled at very low temperature. And the most important property of dinitrogen is inert, right? So that is non-reactive at room temperature because high bond enthalpy, right? So that is a N triple bond with N, right? So whenever there is a triple bond, the force of attraction will be more, right? So you need more amount of energy to break all these bonds, right? So which means to bond to bond a new bond with another element or to react with another substance or another element, first you have to break this bond, right? So then only the nitrogen will be free and it will start reacting with another molecules or another atoms or another element. Therefore, so this breaking of triple bond is not so simple. It's not so easy. Therefore, what happens? The dinitrogen is inert at room temperature. At normal temperature or a room temperature, it is inert, which means it will not easily mix with any of the substances. Therefore, here also they have given it is very low solubility, means so easily it cannot undergo hydrogen bonding in case of water. Therefore, the breaking is not simple. Therefore, the bond enthalpy is very high. Bond enthalpy means the amount of energy required to break this double bond or triple bond or single bond. Any kind of bond, generally we'll call it as bond enthalpy, right? So therefore, dinitrogen is inert. Inert means it is a it is not highly reactive, or it is very less reactive, or there is no chances of reactive in case of several conditions like room temperature, which means generally at the normal temperature due to the presence of triple bond, which means for the breaking of single bond how much you need the energy, so it will be more when compared for the double bond, and it will be greater again for the triple bond. It's not very easy to break all these bond and to make this nitrogen free to react with another substances or another elements, right? So therefore the bond enthalpy is very high. Remember, the bond enthalpy in case of dinitrogen is very high, right? So that is all about the dinitrogen. And along with that, so there is one preparation which is important for 3 marks for your annual examination. So definitely in most of the question paper it is repeated. So go through the old question paper, you will see most of the time the same question from the P block element, that is preparation of ammonia, right? So preparation of ammonia, right? So this process is generally given by the scientist called Haber's, and generally we'll call it as a preparation of ammonia by Haber's process, right? So here in this what happens, so there is one particular arrangement, right? So that is cyclic continuous arrangement of these atoms, and this will locate in one direction to another direction. So due to the transfer, there will be a formation of liquid ammonia at the end, right? So we'll see how this instrument or how this apparatus work, right? So it consists of 3 different units. One is compressor unit, one is pump, another one is catalytic unit, right? So that is the catalyst, right? So that is catalyst chamber or catalytic chamber, we can call it, right? So first one is compressor, second one is pump, third one is catalyst, right? And the fourth chamber is for the the fourth chamber is generally for the collection of the product, whatever the product obtained after the reaction, right? So here if you observe, there are 2 inlets. So in first inlet there is hydrogen gas, in second inlet there is nitrogen gas, right? So whenever they are compressed under the 20 megapascal is pressure, right? 20 megapascal, and at 700 Kelvin, around about 723, exact means 723. So we'll see it is around about 700 Kelvin, and the catalyst used for the reaction is iron oxide. Remember, the iron oxide is generally used as a catalyst. And promoters. Promoter means the chemical substances which increase the activity of the catalyst, right? So sometimes what happens during the reaction, the activity of the catalyst goes on decreases, because at continuously if you use the catalyst, its strength goes on reduces. So therefore that time what we have to do, we have to add the chemical substance which increases the activity, the activating nature of the catalyst, that is generally called as promoters. And Al2O3, aluminum oxide, and KO2 is generally used as a promoters in case of preparation of ammonia by Haber's process, right? So even if they ask for 3 mark, so draw this diagram, right? It's very simple. One is compressing chamber, another one is catalytic chamber, so one is pump, right? And after the formation of product, there is one chamber for the collection of that product after the reaction, that is generally called as the liquid NH3, right? So if you see the reaction is very simple. N2 plus H2, so in presence of iron oxide at the temperature of 723 Kelvin, it will convert into NH3. Very simple. In case of first inlet, we have took hydrogen gas. Second inlet, we have took nitrogen gas. Whenever you mix in presence of the iron oxide as a catalyst, that is Fe oxide I have written, iron oxide, and the temperature range of 723 Kelvin, it will convert into ammonia. Very simple, right? And the catalyst used here is finely divided iron oxide. Finely means very minute, right? So very small particles which are present, we'll call it as finely, right? So finely divided iron oxide. And promoters are the chemical substance which increases the activity of the catalyst, right? So whenever the strength of catalyst reduces during the reaction after some time, then again we can increase the activity of catalyst by using the promoters like aluminum oxide and K2, right? So potassium oxide. And temperature maintained is 723. The exact temperature is 723, or it is around about 700 Kelvin, we can say. So whenever they ask for 3 mark, you must draw this diagram and you must write this reaction as well as the conditions. Conditions for the reaction is catalyst, whichever we used, that is iron oxide, and promoters are the chemical substance which increases the activity of the catalyst. Those are aluminum oxide and potassium oxide, and the temperature is 723 Kelvin. It's a very simple skeleton diagram, right? So that is compressor, that is catalytic chamber, iron oxide and Al2O3 plus KO2, and similarly pump, right? And similarly there is one collection chamber that is generally called as liquid NH3 collection chamber. So it is very simple schematic representation. And if you see the uses of ammonia, what are the important uses of ammonia? So ammonia is generally used in the nitrogenous fertilizers, right? So during the preparation of nitrogenous fertilizer for the fields, right, for the plants, right, and even for the crops, the fertilizers are very important, right? So most of the fertilizers are made from ammonia, right? So therefore for the manufacture of nitrogenous fertilizer, for example, in case of a sand or soil, if there is a less, that is nitrogenous content is there, then we can use, or we have to use in certain conditions, the fertilizers for the plants, right? So to make the plants rich with nitrogen, so therefore it helps for the growth and development of those plants that you have already studied in biology. So therefore we have to use these nitrogenous fertilizers in case of crop cultivation or in case of trees, right? So therefore most of the nitrogenous fertilizers, whatever today they are preparing in case of factories, those are generally made with the help of ammonia. There we have to use the ammonia, like ammonium nitrate, urea, right? So ammonium phosphate and ammonium sulfate, right? So these are the important fertilizers which are prepared by using the, that is ammonia, right? And liquid ammonia is used as a refrigerant, and in case of the refrigerants like your fridge, right? So in that what happens, as a cooling agent generally we use the liquid ammonia, as well as even in case of laboratory also, right? So for different reactions or for the study purpose also we can use the ammonia, right? So if they ask for 1 mark, write any 2, right? So one is, it is used in the manufacture of nitrogenous fertilizers like ammonium nitrate, urea, ammonium phosphate or ammonium sulfate, and it is also used for the laboratory reagent in case of laboratory for the different reactions. And similarly in case of qualitative or quantitative analysis, you have seen, right? So in case of qualitative analysis also we can use that one. And liquid ammonia is used as a refrigerant, right? So that is the most common use. In case of refrigerant as a cooling agent, we can use the refrigerant, that is ammonia can be used, right? So very simple 3 marks question, most of the time repeated, that is the preparation of ammonia by Haber's process. So ammonia can be prepared by Haber's process, very simple. The reaction is N2, that is nitrogen gas, when reacts with hydrogen gas, and the must thing we have to write is, that is iron oxide as a catalyst, and the temperature we have to mention, that is 723 Kelvin, and it will convert into NH3. The schematic representation is very simple. One chamber is compressor, one chamber is pump, and third one is catalytic box or catalytic chamber, and one chamber is for the collection of all the reacted molecules or the product which is formed, that is known as liquid NH3, right? So practice this diagram, so definitely it will be for your annual examination. Okay, we have already seen 2 manufacture or 2 preparations of the compounds which are related to the 15th group, right? So one is preparation of dinitrogen, second one is preparation of ammonia by Haber's process, that is NH3. And the third important preparation for your syllabus is preparation of nitric acid, right? So nitric acid can be prepared in both ways according to your syllabus. One is small scale, that is generally called as industrial scale, or that is called as a laboratory scale, and second one is a large scale. Large scale is generally called as that is industrial scale, right? So whenever you need the product or any chemicals in case of large scale, then we have to go for the laboratory scale, right? and whenever you need but a very less concentration or a very less value, then we can go for the laboratory method, right? So here in this syllabus they have given both the methods, the preparation of nitric acid, right? So nitric acid means HNO3. Generally nitric acid means it is a preparation of HNO3, right? So HNO3 can be prepared in terms of two methods. One is a laboratory scale, and laboratory scale is very simple. In case of laboratory, nitric acid is prepared by heating KNO3, potassium nitrate, or sodium nitrate, NaNO3, and along with the concentrated H2SO4, right? So here in case of acidic medium like H2SO4, we can prepare HNO3, right? So HNO3 can be prepared by reacting sodium nitrate or potassium nitrate. You can take sodium nitrate also, you can take potassium nitrate also. Along with that, whenever you react this with H2SO4, that is sulfuric acid, there is concentrated sulfuric acid in a glass retort, right? So in a glass container, that will generally call it as glass retort. So what happens, whenever the sodium nitrate or potassium nitrate mix with sulfuric acid, that is concentrated sulfuric acid H2SO4, it will convert into, right? So HNO3. It is not a main product, it will be obtained in the side product, that is HNO3 can be prepared in very small scale, that is generally called as laboratory scale, right? So therefore remember, it is very simple reaction. NaNO3, which means sodium nitrate, when reacts with H2SO4, or whenever the potassium nitrate reacts with H2SO4, it will generally convert into HNO3 as a side product. And second important preparation in case of nitric acid, second method, that is Ostwald process, right? So this is very important. So this can be asked for 3 marks again. This is also sometimes repeated question, that is 3 marks. Manufacture of nitric acid by Ostwald process, and there are 3 different steps in the preparation of nitric acid by the Ostwald process. In that step 1, ammonia is oxidized by oxygen. Oxidation means addition of oxygen, generally we will call it as oxidize, right? So ammonia is oxidized by oxygen using platinum catalyst, right? So using platinum as a catalyst, and at the temperature range of 500 Kelvin under 9 bar pressure, right? So the temperature used is 500 Kelvin and the pressure is 9 bar pressure, and it will convert into nitric oxide. Remember, in the first step, the ammonia, right? So ammonia we have prepared in the manufacture of ammonia by Haber's process, right? That is N2 plus H2 will convert into NH3 in case of 723 Kelvin temperature, and different types of catalysts like iron oxide, and along with promoters we have used, right? The same ammonia further can be utilized for the preparation of HNO3, that is nitric acid, right? So in that first step is ammonia is oxidized. Oxidized means addition of oxygen. Addition of oxygen is generally called as oxidation, right? So ammonia, that is NH3, when reacts with oxygen, we will call it as oxidized form, right? So therefore here if you observe, that is NH3 plus O2 in presence of phosphorus as a catalyst. In presence of phosphorus as a catalyst, that is 500 Kelvin temperature, and the condition mentioned are 500 Kelvin temperature and 9 bar pressure. What happens? It will convert into nitric oxide. It will convert into NO, that is nitric oxide. In the first step, nitric oxide can be prepared by reacting ammonia with oxygen, that is oxidation or oxidized form of ammonia will give nitric oxide. Along with that, the side product water molecules is liberated, right? So the main product is nitric oxide. In the second step, what we'll do, the same nitric oxide is oxidized. Again, it is reacted to, remember, oxidation means addition of oxygen, right? So the whatever the product we got in the first step, the same product, if you react again with oxygen, it will convert into nitrogen dioxide. Remember, it will convert into nitrogen dioxide. Very simple. In the first step, there is a preparation of nitrogen oxide. In the second step, there is a preparation of nitrogen dioxide, right? So here if you observe, nitrogen is reacted with only one oxygen. Here if you observe, nitrogen is reacted with 2 oxygen. Therefore, we will call it as dioxide. Very simple preparation in the manufacture of nitric acid by Ostwald process. Remember the process. So therefore, in the first step, ammonia is reacted with oxygen, or oxidized form of ammonia will give nitric oxide. And in the second step, the same nitric oxide when reacts with oxygen or further oxidized, it will convert into nitrogen dioxide. It will convert into nitrogen dioxide, right? And in case of step 3, it is very simple. Again, the product which is formed here, right? So nitrogen dioxide, right? So this will react with, or this is dissolved in water. This is dissolved in water, and it will convert into nitric acid. It will convert into nitric acid, right? So here if you observe, nitrogen dioxide when reacts with water molecule, right? So whenever it is dissolved or whenever you put that molecule, water molecule, what happens? So you will get the nitric acid. It is very simple reaction. That is 3 steps reaction. In the first step, there is preparation of nitrogen, that is nitric oxide, and in the second step, there is a preparation of that is nitrogen dioxide. In the third step, there is a preparation of nitric acid. It's very simple. And this can be asked for 3 marks. Most of the time they have repeated because it is 3-step reaction, right? So once again I will explain. Very simple. Whenever ammonia is reacted with oxygen, it will convert into nitric oxide. Further, nitric oxide reacted with oxygen, it will convert into nitrogen dioxide. Whenever nitrogen dioxide is reacted with water molecule, it will convert into HNO3. Very simple reaction for the 3 marks. So that we have seen 3 preparation. One is preparation of dinitrogen. Second one is preparation of ammonia, that is by Haber's process. And third one is preparation of nitric acid. And further, if you see for your syllabus, there is oxo acids of phosphorus. Oxo acid means whenever the phosphorus react with oxygen molecules, we will call it as oxo. The word itself says oxo acids of phosphorus, right? So the acidic nature, right, for the phosphorus comes due to the addition of this oxygen molecule. Therefore, we call it as oxo acids of phosphorus. And there are some structures. So any structure can be asked for 1 mark, right? Out of this, any structure can be asked for 1 mark. Or even in case of CET, also, right? So they might give any kind of the structure, and they may ask you to find out what is the name, or how many double bonds and how many single bonds are there in case of a molecule. Like this they may give, right? So out of this, right, so one might be for 1 mark, right? Oxo acids of phosphorus, right? So go through these structures. First one is H3PO4. Generally we'll call it as orthophosphoric acid. H3PO4 is generally called as orthophosphoric acid, which means the phosphorus is double bonded with oxygen and single bonded with the 3 hydroxyl group, OH, OH, OH. That is hydroxyl group. Phosphorus is double bonded with 1 oxygen, and phosphorus is single bonded with the 3 hydroxyl group. Generally we'll call it as H3PO4. H3PO4. Generally we'll call it as orthophosphoric acid, right? So after drawing the structure, count the number of hydrogen, right? So if you observe 1, 2, 3, 3 hydrogen are there. Phosphorus is 1, oxygen are 4, 1, 2, 3, and here double bonded oxygen 4, right? So like that you have to check the structure of any kind of molecule, right? So H3PO4 is generally called as orthophosphoric acid, in which 1 phosphorus is double bonded with oxygen, that is phosphorus is further bonded with the 3 hydroxyl group. And again in case of H4P2O7, so here there are 2 phosphorus atoms. So here if you observe, it is P2, 2 phosphorus atoms which are interlinked with oxygen. That is generally called as bridging bond. That you will study in the higher cases, right? So here it is phosphorus is bonded between oxygen, right? So that is oxygen is in between 2 phosphorus atoms, and further it is double bonded with both are double bonded with 1 oxygen each, and both are single bonded with 2 hydroxyl group each. That will generally call it as a pyrophosphoric acid, right? So the molecular formula of a pyrophosphoric acid is H4P2O7, H4P2O7, right? And similarly H3PO3 is orthophosphorus acid. H3PO3 is orthophosphorus acid, which means out of this H3PO4, if you remove 1 oxygen, it will convert into orthophosphorus acid. Remember, there is a greater difference between orthophosphoric and orthophosphorus, which means the H3PO4 is generally called as orthophosphoric and H3PO3 is called as orthophosphorus, which means out of these 3, you can remove 1 oxygen from any of the 3. Then it will convert into phosphorus double bonded with oxygen, phosphorus single bonded with the 2 hydroxyl groups. Along with that, 1 hydrogen bond is formed, right? So that is generally called as orthophosphorus acid. And the last one is H3PO2. H3PO2 means the phosphorus is double bonded with oxygen and single bonded with this OH, and it is again single bonded with OH, right? And here if you remove, here 1 oxygen is again less, right? So this is not present, and due to the presence of here 3 hydrogen and only 2 oxygen are present, 1 is double bonded oxygen and 1 is hydroxyl group, and 2 are hydrogen atoms, 2 are hydrogen bonded atoms. Therefore we call it as hypophosphorus acid, right? Like this they may ask the structure for the 1 mark. They may go write the structure of orthophosphoric acid. You must know the molecular formula, that is H3PO4. Phosphorus is double bonded with oxygen, single bonded with 3 hydroxyl group, right? And if you know this first structure, and you can modify that one and you can convert into pyrophosphoric acid, orthophosphorus acid, and hypophosphorus acid. The main thing is you must understand the molecular formula of the given compounds. Okay, again once we'll see what we have studied today. There is preparation of dinitrogen. It is very simple. Whenever the ammonium chloride is reacted with sodium nitrate, it will convert into dinitrogen. Along with there is a preparation of side products like water molecule and right. And also we have seen some of the important properties of dinitrogen also. Along with that, we have seen three important 3 marks question, that is preparation of ammonia by Haber's process. If they ask for 3 marks, there is no any kind of explanation. Just draw the schematic representation, as well as you have to write one is a reaction, second one is condition. N2 plus 3H2 in presence of iron oxide at 723 Kelvin, it will convert into ammonia. And the conditions used are catalyst, that is iron oxide, and promoters are aluminum oxide and potassium oxide. And similarly, temperature used is 723 Kelvin. And also we have seen some of the uses. It is used in the manufacture of nitrogenous fertilizers. It is used in the preparation of refrigerants. Like liquid ammonia is generally used as a refrigerant, and also it is used as a laboratory reagents also. Similarly, we have seen the preparation of nitric acid also. There is also 3 marks question. So they have never asked the preparation of that is nitric acid in the laboratory scale. Generally, in annual examination, they will ask for 3 marks, that is manufacture of nitric acid by Ostwald process. Very simple 3 steps. In first step, there is a preparation of nitric oxide. Second step, there is a preparation of nitrogen dioxide. In the third step, there is a preparation of nitric acid, right? So in the first step, oxidation. Due to the oxidation of ammonia, it will convert into nitrogen oxide, that is nitric oxide. And similarly, whenever the same product which have obtained in the first step is taken as a reactant in the second step, that is nitric oxide in presence of oxygen, that is oxidation, again convert into nitrogen dioxide. Further, nitrogen dioxide when dissolved in water, it will convert into HNO3, that is nitric acid is prepared. Along with that, we have seen some of the structures of oxo acids of phosphorus, and be prepared with these oxo acids. Definitely they will ask for 1 mark, right? So this is all about the group of 15th element. In the next class, we'll go for the group 15th element and the same study, right? So whatever the stepwise study we have done, first is how many elements are there, what are its electronic configuration and general electronic configuration, physical properties, chemical properties like reactivities, and further there are 2 to 3 preparations of different compounds which are related to the different group elements, and along with that the uses, and the last one is the structures of some molecules which are related to that group, right? So this is a systematic study of different groups, right? So today we have completed the 15th group. In the next class we'll go with the 16th group. Thank you.